So you've looked at bar graphs, line graphs, and circle charts. You probably remember those. You may remember these as well, but you may need a little bit more of a reminder at this. So we're going to talk about stem and leaf plots, frequency tables, and histograms today. Make sure you copy down your target, and I put a sample of a stem and leaf just so you remember what they are. So stem and leaves look like this. The data values would be organized within the stem and leaf chart, but you break up the stem from the leaf, and we're going to define what each part of that is. So copy down your target, and then you're going to have to fill in the definition. So the stem is going to be all the digits other than the last digit of each data value. They should be consecutive numbers. You don't always necessarily have to start the stem with 0. So when we look in this example about the bowlers, the stem is this part right down the middle. And they didn't start at 0 because there were no scores that low. So they started at 12 because the lowest score for the bowlers was 121 for Marty and 124 for Bill. The leaves then are the last digits of each data value. It's going to be the last digit, and those go in the leaves. This is a back-to-back stem and leaf, so these would be the leaves for Marty, and these would be the leaves for Bill. The leaves should be in least to greatest order from the stem. So from wherever the stem is, they go least to greatest. One other thing I do want to note is notice there are no commas over here in the leaves. Okay, we don't put commas in the leaves. That is not a stem and leaf plot, so don't even think about doing it. They don't belong there. Also, if a data value repeats, you may see that repetition in the leaves. That is okay. So repetition is allowed in the leaves. However, in the stems, you would not have the repetition because you're only listing it once. The key then tells you how to read each value. So you're used to seeing stem and leaves like this. You've seen them before where you have one stem and you have all the leaves on the right side. If you are graphing two sets of data, you can do a back-to-back stem and leaf where they share the same stem down the middle, and then each set of data spans out one on each side. So Marty's bowling scores are on the left and Bill's bowling scores are on the right. Copy down these definitions. If you need to pause, please do that now. One thing to note about the key, make sure if you're doing a back-to-back plot, you give me a key for both sides. Look how good this key is. It tells me exactly how to read the numbers. And notice that they use values from their stem and leaf in the key. That way you can see exactly how to read it. So here's where I see the bars, the 14, and then the 1. And they're saying, well, that means 144. So Bill's score was 141 in bowling. And then they give you one on the other side with a 3, the 3, and then the bars and the 14. So the bars kind of signify what the stem is. This means a score of 143. So Marty bowled 143 in that row. What conclusion can you make about these two bowlers from looking at the stem and leaf plots? There's a couple things you could say here. You might say, I noticed that neither one of them scored in the 150 range. That would be fine. You could say that Marty might be a little bit of a better bowler because Marty has 3 higher scores than Bill. Marty scored 162, 167, and 168. Bill's highest score was 160. But overall, I think the best conclusion that you can make is really overall, these bowlers are a pretty good match for each other. Their scores are very closely related. It would be different if Bill's scores were down in the 80s and 90s, or my scores, if I was on here, would be in the 70s or 80s. And then Marty's are up in the 120s through 160s. Marty and I would not be a good match for each other. So make sure you feel comfortable with the stem and leaf. Make sure you listen to all the criteria that I gave you because it is specific, and we're going to practice doing one of these back-to-back stem and leaf plots. I'm going to do the USC side, and then you're going to do the Mount Lebanon side, okay? The season scores for the football teams going to state championship are given below. Use the data to make a back-to-back stem and leaf plot. So the plot's going to have a title, like any chart that we have. We always title, and since we're talking about the season scores, I'm just going to title it that. Okay, and it doesn't matter which side you put, which team you put on either side. The stem's going to go down the middle, so I'm just going to keep USC on the left and Mount Lebo on the right. So I'm going to do the stem and leaf for USC's data, and then you're going to finish it off with Mount Lebo, and then you'll check it with mine. When you're choosing your stem, you have to look at both sets of data together, though. So look for the lowest number, the lowest score you see out of both teams, and look for the highest score you see out of both teams. That's going to show you what your stem needs to span. So the lowest score I see over here is 12. The lowest score I see over here is 7. Okay, so we're going to have to include 7. And then we're going to have to go up to the highest score I see, which is 45. And over here, okay, 45 is still the highest. So it's going to have to go up to there. Now your stem is going to be all numbers other than the last digit. So the last digit here in this data is going to be the ones column, which means these numbers, all the numbers in the ones column, are going to be your leaves. Which means the stem has to go from 0, because the score of 7 would be a score of 0, 7, and it has to go all the way up to 4 right here. So 0, 1, 2, 3, 4. And now we're ready to organize our data. Remember, your stem does not always have to start with 0. Just in this case, we have a score that low, so we need to. I'm going to do USC's data, and then you're going to do Mount Lebanon. So when you're looking at USC's data, start with the lowest scores you see. Do we have any scores in the 0 range? Any numbers that are just in the ones column? No. Any numbers with a tens digit? So I have 15, 19, 12, and 15. Now you're going to organize those lowest to greatest from the stem. So the lowest number I see is 12. Here's the 1. Here's the 2. That's read as 12, right? Then the next lowest number are two 15s. So 1, and then 5, which would be 15, and another 15. We have to write it twice to show that it's in the data set twice. Okay, and then the 19. You're done with the 10s. Move on to the 20s now. The 20 for the stem, 26, 21, and 22. Lowest to greatest from the stem. So 1, 2, 6. When you're doing the next row, try to line them up. Make sure that it's almost like a sideways bar graph. You know, you don't want these numbers to be really squished together and those to be really spread apart. So keep it kind of consistent. Scores in the 30s. 38 is my only one. And scores in the 40s. I have 42 and 45. So 2 is the smallest, then the 5. I'm going to start the key for this side. You're going to do the key for the other side. So I would pick a number that actually exists from your data. So I'm going to pick 2 with the lines and the stem of 1. And that means a score of 12. So the 1 is in the stem. I know it's in the stem because it's between the lines. 2 is the leaf, so that means 12. Pause the video here, do the Mount Lebanon data, then press play to check it. Okay, so see how you did. Check your Mount Lebanon side. Make sure that you have the same number of scores that you had in your list in your stem and leaf. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I had 10 here as well, and I have 4, 5, 6, 7, 8, 9. Oh, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 4, 5, 6, 7, 8, 9, 10. So I'm good. Notice, make sure you added your key for that side of the stem and leaf. Always check for your title and your key before moving on. So we can use the stem and leaf and kind of build a frequency table from there. Frequency table is just another way of looking at the data, but the frequency table is going to show the number of times a data value occurs. So frequency is the number of times a data value occurs. What we're going to do for a frequency table is split up the data values in intervals, and that way we can see kind of where the data falls. So just like we look at the stem and leaf plot and we can see that most of the data falls in the 10s and 20s range, the frequency table will do that for us as well. So using the same data, the season scores together now, make a frequency table of the scores from both teams. Include intervals with a range of 10. So I'm going to snap a picture of our stem and leaf plot so we can see all the data values right on this page. You have it on your notes. So just like we did for our stem and leaf plot, let's put a title on our frequency table. We're talking about the season scores. And we're going to put the USC and Mount Lebanon scores together in this table, okay? Now with the frequency table, you have to break the information up into intervals. Sometimes they give you how they want you to break it up. This problem asks for you to find the intervals with a range of 10. But I don't want you to think mathematically range, like subtracting the largest minus the smallest. I want you to think more about like how many integers are within each range. So frequency table is going to have two columns. We're going to have our intervals, and we're going to have our frequency. You can make your intervals however you want as long as they have a range of 10. So, you might choose your first category to be 0 to 5 maybe. But if you choose 0 to 5, think about how many integers fall in that category. 0, 1, 2, 3, 4, 5. That's actually 6 intervals. We need 6 integers. We need 10 integers. So that's not quite going to work. And if you think about 0 to 10, well, how many integers are actually included within that interval? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's actually 11 integers. So a better way of doing that would be 0 to 9. 0 to 9, count how many integers are within that category. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 numbers in there. Your next interval then should pick up right after that. So 0 to 9, we can't, if we start here with 9 and then go to 17, the problem with that is, what if you have a score of 9? Does it fall in this category or this category? So you can't repeat them, okay? So we're going to pick up at the next integer. All of our scores are integers, so that's why we're using integers. So I'm going to start with 10. And 10, count how many integers you have to go up to. So including 10, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 is your 10th one. Then go on to your next one. So we go on to the next integer down here, 20. Now the nice thing about these intervals is look how you have that repetition, 0, 0, 0, 9, 9, 9. It looks a lot neater than some of our other options. And we'll look at one of our other options, but this is much neater. And my highest score was 45, so that's going to be all the intervals I need. Let's say you did 0 to, or let's say you did 1 to 10. Then your next one would be 11 to 21. Then your next, 1 to 10 actually is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But then 11 to 21, it actually have to be 11 to 20, excuse me. And then you did 21 to 30, 31 to 40. I really like it when you have those numbers repeating when you're determining your intervals. That way you don't make a mistake. So if you started something random, let's say you started at 7, it might not be as pretty doing it that way. It'll still work, okay? In this case, we want to make sure our interval has 10 integers within each of them. Each of these intervals do, and there's no overlapping, so they work. Now all you have to do is transfer your data in there. So how many numbers in this chart over here fall in between 0 and 9? Well, just 1. How many numbers fall in between 10 and 19? Now this is why this is so nice. Well, that's just this row right here. So 1, 2, 3, 4 scores from USC and 4 scores from Mount Lebanon. That's 8 scores within that range. How many in the 20s? 3, 6. How many is in the 30s? 1, 2, 3. And how many are in the 40s? 2 scores. This is your frequency table. It's showing the breakdown of how many data values fall within each interval. Go on to the next video for histograms.